Hello everyone, this is question 9 now on paper 1 from 2022. It says figure 3 shows a sketch of a parallelogram PQRS. Given that PQ is 2i add 3j minus 4k and that QR is 5i minus 2k, show that the parallelogram PQRS is a rhombus. Now a rhombus is essentially a squashed square, so what we'd be looking for is the fact that the length of all the sides would be the same. Okay, so so what we got, P to Q is therefore going to be, we're going to find the magnitude of the length PQ, and to find the magnitude we basically square each of the individual components, the I, j and k component, add them together and square root it. So 2 squared add 3 squared add minus 4 squared, and then square root that gives us root 29. And then QR on the other side, which is the other parallel side, is going to equal 5 squared add minus 2 squared. So it should be 5 squared add minus 2 squared there. So that's 25 add 4, so that's root 29. So therefore it is a rhombus because the two opposite parallel sets of sides are the same as each other. Because we already know that it's a parallelogram, so we've just got to prove that beyond that it is a rhombus. And by considering one of the parallel sides and then one of the others of the parallel sides, that's sufficient to prove that it is a rhombus. Okay, now find the exact area of the rhombus PQRS. There's various ways to do this, but the method that I have chosen is I'm going to find out what PR is, and then I'm going to basically find the area of the triangle PQR and then double it. So PR going across the diagonal is equal to PQ add QR. So we just add 2i add 3j minus 4k add 5i minus 2k, which gives us that P to R is 7i add 3j minus 6k. So we find the magnitude of that by squaring each of the individual components, adding it together and then square rooting it, and that gives us root 94. Okay, so now we've got root 94, so now let's look at our triangle PQR, and we're going to use the cosine rule. Okay, so I could say that that's my A, that's my B, and that's my C. So I've got cos A is b squared add c squared minus a squared over 2 lots of bc. So just subbing in to the version of the cosine rule that we use for finding an angle. Okay, that gives me that cos of x is minus 36 over 58, which simplifies into minus 18 over 29, which corresponds to an angle of 128 degrees, 0.367. Okay. That's fine, but that's not exact. So actually, there's an alternative approach. So once I've got this result here, let's use the fact that sine squared add cos squared is 1. So if we use that, then we can get an exact answer for what sine is going to be. And sine turns out to be root 517 over 29 when we use that. Make use of the fact that sine squared add cos squared is 1. So now the area of the triangle is half AB sine C. So it's going to be half times by root 29 times root 29 times by sine of C, which is root 517 over 29. So we work that out, and that turns out to be root 517 over 2. But there are two, yes, because what happens is the root 29 and root 29 times together to become 29, which cancels with that 29. So the area of the triangle is a half root 517, but we've got two of the triangles because they're congruent, so therefore the area of the whole rhombus is root 517. So yeah, if you could remember to like and subscribe to the channel, that would be really, really helpful with the channel's growth, and I'll see you in the next video.